Welcome back. In this section, we will have a brief talk about loading your UA, the weight and balance, the center of gravity, and aircraft stability. Also, how important it is to use performance data. The center of gravity is not a fixed point marked on an aircraft. It depends on the payload, the fuel, and any structural changes that may have happened. The center of gravity limits and location may be established by the manufacturer. However, the location of that center of gravity may change, as we already know. If there's a payload, if liquid fuel is being used, or if there are any upgrades to the structure. With regards to a traditional aircraft, longitudinal stability or pitching about the lateral axis is the one that's most affected. Center of gravity is an important topic, particularly with safety. So let's take a look. When analyzing stability, it should be recalled that a body free to rotate always turns about its center of gravity. We already know this when we covered the 3 axes. So the effects of the distribution of the aircraft's load has a significant influence on its flight characteristics, even when the load is within the center of gravity limits. This important detail is the difference between a safe flight and an unsafe flight. Performance data is a very important topic. For a small UA operation, it is important to use performance data to predict how an aircraft will perform. As a remote pilot, you need to do your due diligence. If there's an accident, a lawyer is going to look at several possible culprits: the operator, the remote pilot team, the manufacturer of the UA parts, the person or company that last maintained the UA, and the list goes on. Consider documenting as much as you can to support you in the event of an accident. Examples of performance data include load factor charts, which we've already discussed, taking into account any high-density altitude conditions. Also, it's important to have your own performance data collection. This may include battery or fuel efficiency during various types of wind activity. More wind, the more it uses the battery or fuel. Also, indirectly related time in service for parts and scheduled maintenance. Document, document, document. All right, let's take a look at some performance data here. We have an aircraft weighing 30 pounds, executing a 45-degree bank. Take a look at the left-hand side of the chart. Locate the column that says angle of bank. Go down until you find the 45 and move directly to the right. You will find 1.414, which is used to multiply the weight. During the turn, the aircraft will experience a weight of 30 pounds times 1.414, in other words, 42.42 pounds. An aircraft weighing 40 pounds executes a 50-degree bank. In this case, the 50 is not located on the left-hand side, so we're going to have to use the grid chart on the right-hand side. Find the 50 on the bottom, follow the line until you get to the curve, and find its approximation between the 1 and the 2. It appears to be 1.5. This will be your multiplier. 1.5 times 40 is 60 pounds. Let's take an example of a 50-pound UA executing a turn with a 60-degree bank. Find the 60, move up until you hit to the curve, move left until you find the number. Also, you can use the left-hand side for a quicker approach. In this case, we can see that the multiplying factor is 2. So the 50-pound UA times 2, that makes it 100 pounds.